You are welcome back to class Mathematics with Ada. Thank you for subscribing to the channel. Thank you for your encouragement. I really appreciate it, and I really appreciate you. We've done something on indices. Now we'll be talking about logarithm. Another logarithm, we'll be considering the relationship between indices and logarithm. Then we also talk about the laws of logarithm. This logarithm, it is not the one with the use of table. So the one that have to do with laws and the one that have to do with indices. That's what we'll be dealing with here. So there's a relationship between logarithm and indices. These are some of the things that we are going to be looking at. If you have, for example, you have b raised to power of x, and that is equals to n. What do we have? Then what happens? This x can be equal to this log this base this. Yes, so that means from here this is an index. This is in indices form. Yes, this is a question in indices form. We want to write this in logarithm form. What do you have? I'm going to be having log. This one that is the base and this is the power will still form base. So you put this here, that will be base b, then log of n. So this is a relationship between indices and logarithm. You have b raised to power x can be equal to n. If you are to write this in logarithm form, you're going to be having log n base m. So that's it. So which implies that if you're given that you have 10, let's say you have 10 raised to power of 2 to be equal to 100. How do you do this in indices form? You can write this in what? In log form. So that will be what? Log. Don't forget this one that is a base at the left hand side will still maintain to be a base. Then log 100. And that can be equal to what? Log 100, that means log 10 raised to power 2 base 10. So that will become what? You have 2 log 10 base 10. What happens there? This go with this. So the final answer there is true. Now let's talk about the laws of logarithm. If you are considering the laws of logarithm, or okay, before that, let's express 4 raised to power x, which is equal to 100. If you are to express this in logarithm form, you are going to be having log. This one is a base 4. You have 100. That must be equal to this power. I did not write that before, but note that this should be equal to this. So that means this should be equal to this 2. Yes, this should be equal to this x. Are you following me? So here you are going to be having what? Log 100. That can be written as log 10 raised to power of 2. Then this one can be written as log of base 4. So what do we have? You have 10, you have 100, you have 100, you have 4. This is equal to x. Then what do you do next? You still have 2 come to the back. So that means log 4 raised to power x. Yes, of course. Good. So this is how best you can re-express this. So I'm trying to see if we can break down the 100. So you are going to be having 2. This one we have 1 over 2 here. times this one will become 10, and this one will become 2. So this cancel this. That will be equal to x. This is where you can stop. Log 10 base 2 will be equal to x. I will show you what happened here when I introduce the laws to you. So let's continue with the laws of logarithm. If we are having the laws of logarithm, what do we do? So now we look at the laws. What are the laws? They are very, very similar to that of indices. Let's talk about the laws. The laws. 1. Log m plus log n, it is equal to log, open a bracket, m times n. Yes, m times n. This is what you are going to have. This is multiplication law in logarithm. Yes. So that means if you have this, there's no base here. Whether they put base here or they don't put any base, it means they are in the same base. This is a base, this is a base. So this is the log itself. Log m n. Log m plus log n. That is equal to log. Bring us like you're factoring out the log. Log out, then you have m times n. Do you get it? Put your base here if they give you base. Provided they are in the same base. If they are not in the same base, it's not going to work. If they not put any base in the two, it's going to work. It means nothing will be here. So we have the second one. That one too. Let's say you have log. You have m. You have, let me not put anything. Then you have log n. Oh, this place I'm supposed to put subtraction there. So we have subtraction here minus. This can be equal to log, open a bracket, you have m divided by n. Do you see that? This is a division law. When you have subtraction between two logs of the same base, you factor out the log, then you divide the logs. Then 3, if you have log m raised to power n, this can be equal to the power of your log can come to the back. So you have n log m. 4. If you have log n raised to power m, then the log is probably j. The log is j, but the base is raised to power m. What do? When you bring the power of the base to the back, you have 1 over m, then log j base n. Are you following this? This is another log. This is another log. If you also have, let's go to 5. Let me call it 5. The log of 1, log 1 base anything, it is equal to 0. It is equal to 0. The log of n, the log of 1 to the base of anything, it is 0. So you have 6. What other law can I state here? It's done the addition, the multiplication, the division, the power. out of the base. So you have log m base n. This is equal to 1. The inverse will be log. They will swap. So here will be n, here will be m. Are you following me? So this is used when you are changing from one base to the other. For example, you have log k base m. You have to change this to base c. How do you go? You will express, then you write log k base c divided by log this one, you put log m base c. So these are the laws of logarithm, and you should be able to make use of them to solve questions. Let's see one or two examples. If you have, let me check some questions here. Okay, let's solve this one. Let me wipe the board. So if you have this, sorry, I have to be fast. Example, you have evaluate log 4 divided by 9. Then you have base 2/3. What do you have? That will be equal. If you express this, I can see the base. I can see the base in my log already. So I can see this is 4/9. I can express this in index form, and that will be 2/3. Everything all raised to power of 2. Then you have the base also to be 2/3. So we are going to be having the power of this will come here according to the law of logarithm. So you have 2 log, you have 2 divides 3, then this one is 2 divides 3, divides 3, common base, this crosses out this. So our final answer is 2. That is for that. Let's solve another example. If you have a question like this, you have log 49. Okay, let's use this one. Simplify. Simplify log 27 by 4 is in base 2, then minus log 9 by 8 is in base what? Is in base 2. Then you have plus log 1 divided by 24 in base 2. So how do we solve this? The solution, they are in the same base, and because they are in the same base, you can re-express this as log, don't forget, log m plus log n is equals to log open bracket mn. So this will become 27 over 4. Subtraction, that will become division. 9 upon 8, then times 1 over 24, close the bracket, everything in base 2, and that becomes what? That becomes log open bracket 27 over 4 times 8 over 9, then times 24 over 1. So what do we have? 4 here 1, 4 here 2. Don't forget this in base 2, please. I can 9 here 1, 9 here 3. So what do we have? 3 times 2, 6, 6 times 24. That become log 6 times 4 is 24. Keep 2. 6 times 2, 12 plus 2, that is 14. So we have log 144 base 2, and that is still equal to log 12 raised to power of 2 base 2. So that can now be equal to what? 2 log 12 base 2. You can't re-express 12 in the power of 2, so that's how you will leave your answer. That is how the answer will go, except you want to do, yes, 27 over 4 times 8 over 9. Let's change that. Okay, 2, 4 here 1, 9 here 1, 9 27, that is 3. So what do we have? I'm trying to check with my calculator to see we have the correct values. So 27 over 4, you have it over 9. So what happens? You have 1 over 24. Oh, I've changed something here. So sorry about that. So sorry about that. There's an error here. I have in my question, I have 1 over 24 there. Oh, I've actually wiped that too. So this is log 1 over 24 in base 2. So this should be 1 over 24 and not 24 over 1. Yeah, so but if I leave it that way, by 24 over 1, the answer I got initially will be my answer. I just want to follow the question. I'm cross-checking the question. So I want to follow that I'm solving the right question. So you have this. So 2 here 1, 2 here will be 12. Then 3 here 1, 3 here will be 4. Yeah, so sorry, I should have cut with this. I'm eventually going to have log 1 upon 4 base 2, and that will be equal to what? Log 1 over 2 all raised to the power of 2. Then you have base 2, so that becomes 2 log 1 upon 2 base 2, and that is still equal to what? Permit me, you have 2 log 2 raised to power minus 1 base 2, and that is equal to minus 2, that's minus 1 times 2 and you have log of 2 base 2. This and this gone. So your answer becomes minus 2. So it's as simple as that. Let's pick another question so that we can go. Let's pick something else. Let's see. Okay, let's pick this question. You have this. You have this. The question says, what is the log? What is log 49 raised to power of a, this bracket, base 7 minus log 0.01, close brackets, then base 10. So how do we go with this? All you have to do is to express all of them in power form. This one, change this one to fraction. Yes. This one, this is base 7, this is base 10. So change this one, express this in 7, in power of 7. So you have log 7, 49 is 7 raised to power 2. Close this bracket. There is a particular a still in the power. Do you get that? Then base 7. Then minus log what? 0.01. That means 1 upon 100. And you have this 10. Do you see this? This will become what? It will become log 7 raised to power of 2a. Indices, power law. Power multiplies power. Base 7 minus, this will become what? Express the power of 10 as 1 over 10. Everything raised to power of 2. Don't forget in base 10. And this will become what? This will become 2a log 7 base 7 minus 2 log 10 base 10. The log of any value to the same base, it is 1. I hope I gave that in the log. The log of any number to the same, to its base, the log of a number to its base, the same value, you have 1. So this will become 2a minus 2. And what do we have? We are going to be having what? We have 2 open bracket of a minus 2. That is it. In fact, oh sorry, we have minus 1 there. So we should have minus 1. So that when you expand, you get this back. Thank you very much for staying with us. Thank you for watching. I do really appreciate you. Please help us more by sharing with your friends, sharing with people that need it. Tell others about mathematics with Edu. And if you want us to tutor you for any exam, student, your child, your kid, either home teaching, virtual class, online class, we are much available. I'm much available with my team member. So reach me on this number 081 64 86 9470. Thank you for your time. We'll see in the next video.